Data has gotten big, exabyte big. What's an exabyte? Put it this way, take 100 million hours of AI-generated video and you've got one. And that means a lot of storage, not lightweight storage. This is heavy-duty work, as in millions of hard drives. Now going this big actually means starting small, not millimeters, nanometers. That's how we fit this much information into such a tiny space. We're talking lasers smaller than a grain of sand, controlled by custom nano-scale chips. Throw in some plasmonics, magnetics, robotics, spintronics, all built from crazy quantum devices. Take a few groundbreaking innovations in material science and some of the most complex atomic-level engineering known to man, and you're on your way to building a modern hard drive. Of course, making a single unit of cutting-edge technology like this is one thing. 50 million a year to store the world's data? That's another story. To do that, we first need to source the raw materials. Simple, right? Problem is, to make a hard drive, you need over 60 elements from the periodic table coming from every corner of the Earth. And once you've found them, you then have to figure out how to move them. That's where a worldwide supply chain, connected by a finely tuned system of logistics, comes into play. Getting the exact amount of each material to the right place at the right time. Okay, so we have all of our materials, but there are hundreds of minuscule bespoke parts that go into a hard drive, with some taking over 2,000 precision steps to manufacture. Producing millions of these individual components a day requires an unprecedented level of automation, as in factory AI, computer vision, and wildly advanced robotics. But equipment capable of producing laser modules and printing them directly into tiny nanomachine sliders isn't something you can just pick up down the street. So we custom engineer manufacturing robots to build these parts with atomic-level accuracy. And don't forget, this is happening simultaneously across multiple production lines 24/7 in facilities spanning 3 continents. Maintaining this multi-exabyte output every day means smoothly orchestrating hundreds of logistics pathways that crisscross the globe with perfect synchronization. Looks easy when you've been doing it for decades. AI control systems monitor a non-stop stream of real-time data analytics to ensure that every step in the manufacturing process continues not only without interruption, but with maximum efficiency. Think that's all? Not quite. Once every component is built, they all have to be integrated with the same level of precision into that magical little box that fits in the palm of your hand. Advanced telemetry, HPC, state-of-the-art machine learning. Just a few things that go into testing the limits of every drive for performance and durability. And when you've got one that passes without losing a single bit of data, the only thing left is to do it again and again, until you have enough to ship hundreds of exabytes of capacity out into the world year after year. What's really in an exabyte? It's atoms and algorithms and artistry. It's half a century of expertise perfecting the process. It's the context powering tomorrow's creativity, discovery, and invention. And it's just the beginning. Because data isn't slowing down, it's scaling up. Which begs the next question. What's a zettabyte?